Okay, we are doing polynomial operations today. So we're going to add, subtract, and multiply our polynomials. Okay, we're going to get started. So if I have f of x equals 3x plus 2 and g of x equals negative 2x minus 1, I want to find the following things that I'm going to give you. So first I want to find f of x plus g of x. So this is where we went awry yesterday. What operation is happening here? Oh, one of you knows. What about the rest of you? What is that operation? The same person still knows, but what about the rest of you? This is our addition operation, yes. Okay, we have addition. And what am I adding together? I'm adding f of x and g of x, which are my two functions, okay? And those are given to me. So I know that f of x is what? What is f of x? Okay, so I have 3x plus 2. And then my operation is addition. And what is my g of x? Negative 2x minus 1. So if we look at this top row right here, that's our notation. The second row that I wrote, that looks like your warm-up, doesn't it? Yeah. So pretty much, I'm just giving you function notation, and you're writing it into like the warm-up form. So can we do 3x plus 2 plus negative 2x minus 1? Okay. Do I have to change anything, or can I just add it? We can just add. So what I'm going to do, I'm going to rewrite it without parentheses. So 3x plus 2 comes down. I get to keep that as a minus 2x and a minus 1 since addition doesn't change the signs. And now what do I do? Now I can combine my like terms. Thank you. So 3x, does that have a like term? What is its like term? Perfect. And what is 3x minus 2x? 1x or just a plain old x? Now, what about 2? Does that have a like term? What is its like term? Negative 1. And what is 2 minus 1? Positive 1. So here is my final answer for this first one, okay? Okay, next, we said it's probably going to be subtraction. Let's look. Is it? Yeah, so I have f of x minus g of x now. So I have f of x, which is the same from before, is 3x plus 2, minus g of x, which is negative 2x minus 1. Now, this was the one on the warm-up where you all went, oh, what do I have to do when I'm subtracting? Change the sign. What do I do with the negative, the subtraction? Didn't I distribute it through? By distributing, that lets me change the sign. So 3x plus 2 stays the same. Plus 2x plus 1. What do I do next? Combine like terms. What are my first like terms? 3x and 2x, and that gives me... And next. 2 and 1 is 3. So here's my answer. What's our next operation going to be? Multiplication. So division is an operation, but we're not going to worry about that right now. We'll do that in the next unit. But our next operation for this is going to be multiplication. So we're going to multiply f of x times g of x. We know how to do that because I just went over it again. So I have 3x plus 2 times negative 2x minus 1. And what method do I like to use when I multiply? The box method. Does it matter to me what method you use? No. As long as you get the right answer, okay? But when I show it to you, I will always be using the box method because I think it sets everything up the most neatly and it translates the best over all of the polynomials that we have. So I'm going to put 3x plus 2 across the top and negative 2x minus 1 down the side. Does it matter which binomial goes across the top or down the side? No. I'll get the same answer either way. I just normally put the first one across the top and the second one down the side. So in my top left box, 3x times negative 2x is what? Negative 6x squared. Good. Now down. 3x times negative 1 is what? Negative 3x. Across the top, negative 2x times 2.
Negative 4x.
And 2 times negative 1.
Negative 2.
Perfect. Okay. Now if I look right here, more often than not, those diagonal values will be my like terms. So I can do this one of two ways. I can rewrite all the terms. It's negative 6x squared minus 3x minus 4x minus 2 and combine from here. Or I can look and say negative 3x and negative 4x. Oh, I know that's negative 7x. So I have negative 6x squared minus 7x minus 2. You don't always have to write this line right here. And if I'm being perfectly honest, I don't always write it. Normally, I will just look at my box and combine my like terms from there, okay? How are we so far on these three? Pretty simple? Say you're hungry? I know. Okay, we have 2 examples now. 2 examples. It looks like it's a lot, but I promise it's not. It's not. So it says, number 1, f of n equals 3n squared plus 3n to the 4th minus n cubed. Copy this down because you're going to say, wait, slow down, let me write, because you're talking right now. And g of n equals 7n squared plus n cubed minus 2n to the 4th, okay? What operation am I doing for number 1? What operation? 2 of you know. Out of 35, that's not good odds. What operation is number 1? And that was a little bit better. And then what is the operation for number 2? Multiplication. Okay. So number 1, first I have f of n. I'm going to write that. It's 3n squared plus 3n to the 4th minus n cubed. We said our operation is addition. And I'm going to add g of n, which is 7n squared plus n cubed minus 2n to the 4th. Now to add these polynomials, what do? I just get rid of the parentheses and combine my like terms. Thank you. Okay, so 3n squared. Oh, my nose. 3n squared, does that have a like term?
Yes.
Yes. It is 7n squared. Do we agree with that table? No, you can't agree with yourselves. I'm asking the rest of the class. Do they agree with you? Do we agree those are our 2 like terms so far? Okay, what is 3n squared plus 7n squared? 10n squared. Okay. It's okay. Rookie mistake. First time. Okay, what about 3n to the 4th? Does that have a like term? Yes. Which one is it? Thank you. Negative 2n to the 4th. So what is 3n to the 4th minus 2n to the 4th? 1n to the 4th, and it's positive, so I'm just going to write a plus. Gentlemen, I know you're excited, but shh. Finally, I have negative n cubed and positive n cubed. So what happens there?
0.
They cancel each other out. They equal to 0 when I combine them. So I'm left with 10n squared plus n to the 4th. Now, the last thing I want you to do is we're going to write our polynomial in order from highest degree to lowest degree. So n to the 4th is greater, because that exponent is higher, plus 10n squared, and that's how I would look for your answer, okay? Does that make sense? Okay. Okay, now on number 2, we're saying multiply. So I want to do g of n times h of n. So g of n is n plus 5 times h of n is 4n plus 4. Okay, so I'm going to multiply. Yes. What was this one? This was my answer.
Oh, okay, never mind.
Okay. So I have n plus 5 times 4n plus 4. Okay, so I have 4n squared, 4n, 20n, and 20. Now, are my two diagonal numbers, are those like terms in this case? Are these like terms? Yeah, so I'm just going to combine them from there. So I have 4n squared plus 24n plus 20. Okay, do I have a GCF between these three numbers? Yes, do I want you to take it out? I do not want you to take out the GCF. Okay, so you're going to look at this and say, Miss Did I remember the GCF is 4 and you're going to divide it out? I'm going to say, no, don't do that, please, because I didn't ask you to factor, I didn't ask you to divide. So the whole point of multiplying is to expand our polynomial. So I want to keep it all the way expanded. If I gave you this answer and said find the factors, then you'd take the GCF and factor. But otherwise, 4n squared plus 24n plus 20 is the answer that I want from you, okay? Ready for two more?
Why are you guys listening to what I'm saying?
Okay, what is my operation for number 3? Number 3. What's my operation on number 3? Multiplication. And on number 4, it is good. So we want to start thinking about that. On number 4, I have g of n times h of n. So that's n minus 5 times 2n minus 5. Are you guys okay back there? I hope you're okay back there. So I have g of n times h of n. So I'm going to start 2n times n is 2n squared. Negative 5 times n is negative 5n. 2n times negative 5 is negative 10n. And negative 5 times negative 5 is positive 25. These are like terms again. So I'm just going to combine. I have 2n squared minus 15n plus 25, and that's my answer. So do you see how on these ones they've all come out in order by highest degree to lowest degree? That's just happened, and that's just, a good convention. That's just a good way to write it, okay? Finally, on number 4, we have subtraction, yes? Yes or no? Yes. Okay. So I have f of v first, which is 3v squared minus 6v plus 5. And for those of you who said, I thought you were going to give us a quadratic, we're going to do plenty of quadratics next week, so just wait. So this is subtraction. It's minus g of v, which is 2v plus 5. And what do I do again with my subtraction sign? I know you're ready for lunch, but what do we do with our subtraction sign? Distribute. Thank you. So I have 3v squared minus 6v plus 5 minus 2v minus 5. Okay, does 3v squared have a like term to combine with? No, so I'm just going to rewrite it. And another thing I'd like to do is cross it off so I know I already took care of it. What about negative 6v? Does that have a like term? Yeah, what is it? Negative 2v, and how do they combine? Negative 8v. And what about 5? Does it have a like term? Yeah, negative 5, but they cancel out, they become a 0 pair. So that means 3v squared minus 8v is my answer. Do you remember doing this last year? Yeah. Move on. So on this next slide, there's not a lot to write down, but I need you to focus first. Please listen first. I'll wait, because this is important. So I have, if f of x equals 3x plus 2 and g of x equals negative 2x minus 1, what do the following things mean to do? So this came from our first slide, right? It's the first thing we started with. So what does this mean? If I give you f of x plus g of x, what does that tell me to do? Good, I'm going to add the two functions, right? What if I gave you f of x minus g of x? I'm going to subtract the two functions. And then finally, what was the last one? I'm going to multiply. I have f of x times g of x, okay? Now, I have a different notation for this. The next thing I'm going to show you is exactly the same. You do the same thing, it's just written differently. And for some reason, this notation trips up my students a lot. So, I have f plus g of x. What is different about that compared to what I originally had?
You're adding f and g to the x.
Yeah, it's written a little bit differently, right? Like I have f plus g in one set of x. So before I had f of x plus g of x, now I wrote f plus g of x. So one of the things I notice is you guys do f plus g correctly, but then since it has that of x thing, you multiply it by an x at the end. Is that what you're supposed to do? No, it literally means f of x plus g of x. So then for subtraction, what do you think that looks like? F minus g of x. It's exactly the same. And then what about multiplication? F times g of x. So these three notations are equivalent. You will see both of them. So we have our add, subtract, and multiply. Can you write down this little chart, that little 3x3 about add, subtract, multiply? Because you will see both notations on quizzes, on tests, on homework, on the SBAC. They mean the same thing, just written differently. Now we are moving on. I have two more examples. Number 5, what is the operation that I'm doing? Subtraction. And this is the same as writing f of a minus g of a. F of a minus g of a. Okay? And that's just because my variable is a this time. It's not x. So this means the same thing. It means the same thing as f of a minus g of a. So, I have 3a cubed. I have 3a cubed minus 2a. All of that minus a minus 3. And what do I do again with subtraction? What does the subtraction sign tell me to do? It does tell me to subtract, yes. But what do I need to do to my polynomial?
You distribute.
You have to distribute and then switch the sign. So thank you, both of you. So I have 3a cubed minus 2a minus a plus 3, right? Does 3a cubed have a like term? No. Does negative 2 have negative 2a have a like term? Yes. What is it? Negative a. So what do I get? Good. Negative 3a. And then does that plus 3 have a like term? No. So that means 3a cubed minus 3a plus 3 is my answer, okay? Let's look at this last one. I have h of x equals 3x minus 1 and g of x equals x squared minus 5. What is my operation? Multiplication. So again, this means h of x times g of x. Now this part right here, do you need to write that on your quiz or on your test, on your homework? No. If you need to, yeah, go ahead, but I'm not going to make you. If you need to write that for your own reference because you won't know how to do it otherwise, go ahead and write it, but I'm not checking for that. So I have 3x minus 1 times x squared minus 5. So I want to use the box method again. So I have 3x minus 1 times x squared minus 5. What is 3x times x squared? 3x cubed. Good. Okay. Now what about 3x times negative 5? Negative 15x. What about negative 1 times x squared? Negative x squared or negative 1x squared, and negative 5 times negative 1 is a positive 5. So let's look at these diagonal terms. Are they like terms this time? No, why are they not like terms? Yes, and that's because in my original factors, or my original binomial, I had an x squared term instead of just an x term, okay? So if I look at those four monomial terms, do I have any like terms to combine? No, so I'm really just going to write it in order by descending or greatest to least exponent. So I have 3x cubed minus x squared minus 15x plus 5. I can't combine any of that, so this is my answer, okay? Any questions about that? Okay.